Now our problems are going to start getting a little more difficult, so let's take a crack at this, see if it only takes me one take to get through this video. So here we go. After she starts measuring, when is the first time the depth of the waves is at its average value? So give an exact answer. So I want to point out we have a negative sine curve here. I guess I should have read this part. Gajal holds a ruler in some wavy water. The depth of the water, t seconds after she starts measuring it, is given by this function here. So we have a negative sine curve. So if you were to graph it, you know that it's going to start on the midline. And since it's negative, it's going to go through the valley first. Now notice it's been shifted to the left. Oops. So it starts to the left. It's above the x-axis because it has a midline of 50. And so what we're going to be answering is when does it return? Basically, when's the first time after she measures time? So she's going to start measuring time right here, right at the y-axis. And actually, I should draw this a little bit lower. Let me just redraw my coordinate plane. Just so we can get an image here. So right here's where she'll start measuring. It may not be right on the minimum, but basically on the y-axis, wherever it's at is on the y-axis, she starts measuring. We want to know when do we get to that midline again, because after she starts measuring, when's the first time the depth of the waves is at its average value? So we're starting to the left at negative 0.23. So this point right here is negative 0.23. And its y value is 50. So that's where this point is. So we're starting to the left, negative 0.23. So we're going to have to go halfway through the period to get to the midline the first time, because really it doesn't start till right here. So starting right there, we want to figure out where is this at. So it's halfway through the period. So what is the period? Let's start with that. So the period equals 2 pi over b, which is 2 pi over pi, which is 2. So a halfway through the period is going to be 1. Half of the period equals 1, right? So if we're starting at negative 0.23, the x location, that's when it's first is going to be the negative 2.3 plus that 1, which is going to be 0.77. So you got to kind of picture what's going on here. And so our period is 2. We want half of that period. We want to get to that midline there because technically it's been shifted to the left. So we want the first time it gets to the midline after the y-axis. So when is the first time? So right there. So from here we add 1. That's half the period. All right, here's a little more direct forward. It's just asking what's the period of the light from the moon. So the light from the moon on the night of the 10th day of 2016 is given by this equation. So the period, in this case, b is going to equal 2 pi over 28.5. So the period is going to be 2 pi over that. So remember, we have to create a fraction over a fraction. So that way it's going to be 2 pi over 1 times 28.5 over 2 pi. The 2 pi's cancel and we get 28.5. So quite easy for that one, right? That's going to be the period. A pendulum is swinging next to a wall. The distance from the bob of the swinging pendulum to the wall varies. So realize that h is the distance from the pendulum's bob to the wall. So we have a wall again. Here's our wall. Here's a swinging pendulum. And as we get closer to the wall, our distance is actually decreasing, right? So let's read through this. The function h has a period of 0.8. So p equals 0.8. A midline We always call that D, right, of 15. And then at time t equals 0.5, the bob is at the midline and moving towards the wall. Oh, it has an amplitude. I was thinking, I was like, man, they didn't give us an amplitude. So we're starting on the midline. So since we're starting on the midline, we're going to use the sine function. And if we're moving towards the wall, that means we're decreasing. If we're starting on the midline and moving towards the wall, that means our height is decreasing, or that distance from the wall is decreasing, right? So using this information, we know it's going to be a negative sign since it's decreasing. So negative 6 sine of, we need to come up with b. It's been shifted to the right because we're starting at 0.5 seconds. So we're shifting to the right 0.5 seconds is where we're starting this. And we're at the midline of 15. So we just need to figure out what is b. So if period is 0.8, then that means 2 pi over b equals 0.8. 0.8 over 1. Cross multiply, so 0.8b equals 2 pi. So b will equal 2 pi over 0.8. And that's what we're going to put right here. And that's it.